Mike with Electric Lab. Today we're going to be covering from the 2026 National Electrical Code calculation of a dwelling unit service using the standard method. Now there's definitely been some changes in our new edition of the NEC regarding this calculation. So we're going to break down each one of those pieces, talk about the general lighting load, the fixed appliance load, the HVAC load, largest motor, and electric vehicle loads, and ultimately being able to size your conductors and determine what size service you're going to need and what size conductors you'll need to do it with, along with your grounding electrode. So let's get started. Okay, so here we go. This presentation is based on what is called the standard method load calculation for single-family dwellings. The other method, titled optional methods, is not covered in this presentation. Determining the proper size of a service for a dwelling unit is of great importance. This procedure done incorrectly can cause a variety of problems. Understanding the various components of this calculation will also be invaluable if you are preparing for your licensing exam. It is unlikely that you would be asked to size an entire service on the exam, but very likely that you would be required to size the various components of the calculation. And I should add this caveat in there that that's really speaking toward the journey level exam. I think you could maybe on the master's exam have a requirement to calculate an entire dwelling unit. And those various components would be general lighting load, fixed appliance load, HVAC load, the largest motor load, electric vehicle supply equipment load, neutral conductor load, and sizing the phase, neutral, and grounding conductors. This presentation is based on the 2026 NEC. And yes, you might already realize there are a great deal of changes that have occurred in this code cycle. Extensive changes were made in this code addition to this article in particular. Article 220 is now Article 120. The entire article was moved and some sections were relocated or even deleted. As we work our way through this calculation process, we will identify some of those areas affected. Demand factor. Many branch circuits and feeders have utilization equipment that will not be used at the same time. Therefore, the total load on these circuits may be reduced by a percentage called the demand factor. And a demand factor is a percentage that the load on a circuit may be reduced to create a lower electrical load. Now, before any calculation can be done, first the total code required square footage of the structure must be determined. How big is the house? And if we go to Article 120.5C, the floor area, it says the floor area for each floor shall be calculated from the outside dimensions of the building, dwelling unit, or other area involved. For dwelling units, the calculated floor area shall not include detached garages, open porches, or unfinished areas not adaptable for future use as a habitable room or occupiable space. So I interpret that as if I have a crawl space, well, of course, that's not a habitable area. If I have a completely unfinished basement, nothing but concrete walls, that area could be finished off into a habitable space, at a later time. So when calculating these, in the way I see this and read that description, I would include that square footage also when calculating this load. Although the NEC refers to this calculation as a general lighting load, this is what we're working on first, the general lighting load. This load also covers small appliances, laundry units, bathroom requirements, and most receptacles throughout the home. The NEC Article 220.41 specifies the number of volt amperes for each square foot of a dwelling unit. For dwelling units, that number is now 2 volt amperes per square foot of living space. This 2 VA is a decrease from the former number of 3 VA that was used in previous code editions. And we're also, if you look in the 2026, there is a section that speaks regarding determining the calculated load for branch circuits. And when using that calculation, you still calculate it at 3 volt amperes per square foot. But when calculating the service load, you're using 2 volt amperes per square foot. Now, Article 120.41, motors rated to 8th horsepower or less and connected to a lighting circuit shall be considered part of the minimum lighting load. An example is a bath exhaust fan. Those are negligible loads. They're pretty low level. So Article 120.52A requires 2 small appliance circuits calculated at 1500 VA each. And that is the bare minimum. The code, of course, is the bare minimum. In a lot of kitchens, you're probably going to have more than that because you're just going to have more receptacles and have more of a load to deal with. Article 120.52B states a load of 1500 VA shall be included for each laundry branch circuit, also known as the clothes washer. So that's at 1500 VA also. Now, per table 120.45, lighting load demand factors. The first 3000 VA shall be calculated at 100%. The remaining amount shall be calculated at 35%. So once you determine those first factors, the square footage and the small appliance load and the laundry load, whatever that total is, you will deduct 3000 VA from that, and then the remaining amount you'll multiply by 35%. Now, below here, it also says up to 120,000 VA. Once you get up to that level, then you would actually use 25% instead of 35%. Okay, so now let's calculate the general lighting load. So let's say we have a 2,500 square foot home. It is being calculated at 2 volt amperes per square foot. That means that I'm going to have a total of 5,000 VA for that first calculation. And that includes general purpose receptacles and all the lighting, right? Now, number 2, and notice I've got the articles on each one of these lines, 120.41 for general, 120.52 for small appliances. So our code states that the bare minimum is 2 small appliance circuits, and those are calculated at 1500 VA each. So that's going to be 1500 times 1500, or plus 1500, excuse me. That's going to be 3000 VA. And our laundry load, of course, according to 120.52B, that's going to be 1500 VA. Now we add all those together, 5,000 plus 3,000 plus 1,500. That gives us a total of 9,500. Now, this is where it gets interesting. Notice here where it says 3,000 VA. The first 3,000 VA is calculated at 100%. So we're going to type it onto the line here also. So that's our 3,000 VA. Now it says subtract the first 3,000 VA from line 4. So that's going to be 9,500 minus 3,000. That gives us a total of 6,500. Now, the 6,500 is calculated at 35%. So 6,500 times 35% is going to be 2,275. And as you can see, that dropped pretty good. Now, adding back in that 3,000 VA, you can see it says add lines 5 to line 7. That's going to give you a total of 5,275 for your calculated load for general lighting. And as you can see, that does drop quite a bit, but that's using the demand factors applied and the components applied. Now, this is the reason I brought this out as one piece, and I'll go general lighting, fixed appliance, and so on and so forth. I believe that in a journeyman's exam type scenario, you could have this question alone on the test, and it could simply ask you to determine the general lighting load per the NEC, and all that really tells you is that a square footage, and then you would put exactly what I've got here, 2 small appliance circuits, the laundry loads, and then you have to know what we're doing on 5, 6, 7, and 8 in order to get your calculation correct.